All right, for problem 16, I'm going to go through this problem. If when I'm done going through it, if it still doesn't make total sense, I'm going to highly recommend that you re-watch the Euler's method video that I had posted to kind of make sense of this and to get a little more exposure to it, okay? So it says let y equals f of x be the solution to the differential equation dy dx equaling x minus y with the initial condition f of 1 equals 3. What's the approximation for f of 2 obtained by using Euler's method with two steps of equal length starting at x equals 1? Okay, so this is a series of tangent line approximations, and round one would just be finding the equation of the tangent line to the function at where x equals 1. So round one, you're going to get the slope of the tangent line at the point 1, 3 just by plugging in 1 for x and 3 for y in the derivative function. You'd get -2. And then you get the equation of that tangent line at that point. Your point of tangency is 1, 3, and your slope is -2. So y minus 3 equals -2 times x minus 1. And then you isolate y by adding the 3 over. Okay, and so here, this is the equation of the tangent line to the graph of f, y equals f of x at the point 1, 3. And then it says to use two steps of equal length, and you need to get from 1 to 2. So you have 1 unit, and you're going to split that unit into 2 subintervals of equal size, so each one is half a unit long. So since this is basically centered at 1, you're going to add 1/2 to 1 and plug in 1.5 to this line graph. Okay, so when you plug that in, you end up with 3 minus 2 times 1/2, so just 3 minus 1, or 2. So what we could say is that the actual function, if you plug 1.5 in, you wouldn't get 2, but you'd get something pretty close to 2. Okay, so that's the end of round one. And then for this problem, you'll need 2 rounds. So round 2, what you do is you treat 1.5, 2 like your new point of tangency. So I'll just say 1.5, 2 is your new point of tangency. And then you plug that in to get your next slope. So dy dx at the point 1.5, 2. Okay, just plugging 1.5 in for x and 2 in for y, it looks like I'd get -1/2. Right, and then the equation of this not so tangent line, I suppose, would be y minus 2 equals your slope times x minus 1.5. Isolating y just by adding the 2 over. Like so. And then the last thing you're going to do is plug in 2. So this was centered at 1.5. You bump it up by half a unit. And so you'd have y when x is 2 would be 2 minus 1.5 times 2 minus 1.5. And so f of 2 would be approximately what we're going to get here. And so 2 minus 1.5 is 1/2. 1/2 times 1/2 is 1/4. 2 minus 1/4 is 1 3/4, which is also known as 7/4. So hopefully the answer was C. All right, again, if that does not make total sense, I do recommend you rewatch the Euler's method video.